All right, so lessons 4 and 5 today. So we're going to talk about bonding and then specifically ionic bonding. So you've heard of bonding before, I'm sure, in another science class. Remember that a compound is two or more elements bonded together. Formula is going to be the new way that we're going to write things out. So if there's more than one of each element, you know by their subscripts. So for example, water is composed of H2O, so there's two hydrogens. One is assumed, so one oxygen. Valence electrons would be the number in the outermost energy level. You probably talked about them in terms of rings in the past. They're going to be the chemistry electrons that we're going to get to more about later. But the octet rule is going to be really important this year. So they're looking for any element's looking for 8 electrons, okay, 8 valence electrons. And if not, they might have some charges. So there's two things here that are going to be important to be familiar with this year. Cations and anions. So cations are going to refer to the positive charge, okay? It's going to be elements that have less than 4 valence electrons. It'll be easier for them to lose to get to 8 than try to gain a bunch more. So, for example, Mg+2 is a magnesium cation. You can always think of cation in terms of cats are positive, okay? So cats have pos, cats are positive. Anions would be something that has more than 4 valence electrons. They're just going to gain some electrons to get closer to 8. So that makes them have a negative charge because they have more electrons than protons. So based on the number of valence electrons, basically the charges can be assigned to the columns of the periodic table. So if you're in the first group, so it starts with hydrogen as +1 charge, beryllium second +2. The middle in the transition metals doesn't really follow this rule. So we skip over to boron +3, carbon ±4, nitrogen -3, oxygen -2, fluorine -1. The last column already has the 8, so they're good to go. Okay, so let's try some practice here. So if our element is calcium, I look and figure out which group it's in. Well, it's in the second group. That means it has a +2 charge, making it a cation. And it's going to be named pretty normally. So if we look back up here for the naming, so it's just called magnesium cation. The anions are just changed to an IDE ending at the end. All right, so if we look at this, this is going to be called the calcium cation. Let's try fluorine. So fluorine's in the 7th column there, so it's the very top. So it's also right up here. Since it's one away from being in the 8th, it's going to have a -1 charge. And it will be an anion, and it's going to be called fluoride. So instead of fluorine, it's now an IDE ending. All right, so now we're going to apply these ions into naming them and writing their formulas. So in order to write their formulas, basically we're going to follow some steps. The first thing you're going to do is write the symbols of the elements that you want. Okay, metal always goes first, then the non-metal second. Write the charges from their column as a superscript, so +1 and -2. You're going to crisscross them and bring them down. So since there's a 1 here, it's going to come after the sulfur. It's implied right here. The sulfur's -2 is going to come down. It's going to be Na2S, okay? Then you go ahead and make sure it's written in the lowest whole number ratio. So for example, if you were to do magnesium and oxygen, you would get Mg2O2. Reduce that, so it's just MgO. All right, so let's try an example here. So let's just go ahead and look at the first one. So we've got sodium and nitrogen. First thing I'm going to do is write out their symbols. So sodium's +1, nitrogen is -3. Okay, so I wrote their symbols and their charge. Next thing I'm going to do is crisscross these charges, and the numbers are going to come down. So we have NaN. Remember, this 1 is just implied. I don't need to write a 1 here. But that 3 comes down, so it's going to be Na3N. All right, let's try one other one. Let's try this one. So aluminum and selenium. So aluminum is Al, selenium is Se. If you find them, aluminum is +3. Selenium is going to be -2. Crisscross these, bring them down. So we're going to have Al2 Se3. Now to name these is a little bit more straightforward. Basically, you're just going to keep the first exact the way it is, and the second one is just going to end in IDE. So for example, if you have NaCl, it would be sodium chloride. Okay, so let's try some of these after we look at some examples: magnesium bromide, aluminum sulfide, and so forth. So we have this first one. Well, the first thing is called just as is, so magnesium. And then P is phosphorus, but instead of writing phosphorus, we're just going to write phosphide, and that's it. Give another 1 or 2 of these a try so you're more comfortable with this, but we're going to keep working with this all year.